Hi there. In this video we will be taking a look at this Hama power pack 10,000 milliamp hours power bank, basically portable battery. So let's get to it. And also, just because I have one, I will be comparing this to this Hame, not the same brand, again 10,000 milliamp hour power bank. This thingy can do 2 amp, 5 volt 2 amp input and 5 volt 2 amp output, and the model H13. We will be testing both of them to see if they show the maximum ratings that are on them. They can do that, and we will be also testing the capacity. On this one I'm quite certain it will be less than what they say in here. On this I'm quite hoping that it will be what they say in this, but you never know. This has way more ports. We will be taking a look in a moment, and in theory it's a bit more beefy than the other one. It has a few protections in here which are quite good. Let me try and show you. Yeah, I'm going to show you in Romanian, and now hopefully I can peel this off and also show you the info on it in... No, I cannot. I hate this kind of labels, zero chance of peeling it off. It's basically telling you that it's for mobile phones, smartphones and whatnot. Maybe you can read any of the other languages in here. Anyway, let's see. So input 5 volt 2 amp. It should be charging about the same as the other one. Output, in theory, it has a bit more power to it, so it can do 3 amps instead of 2 amps on the other one. And minimum capacity, we can see it here. Oh, I have something in here and it will annoy me, I need to cut it. 9960 milliamp hours is the minimum, and these are the dimensions. I will also test the weight between these two. This I'm just putting in the mix because it's the same capacity and it's an older technology. This has between 5 and 10 years of age. It hasn't been used too much. I think I used it 10 times, 15 times maximum. So it's not worn out. I didn't damage the cells, but it's older technology of the lithium cells. So I'm quite curious how these two stack up. Anyway, so let's see, open here. Okay, they give us a bit more info. So input is either this micro USB or the USB Type-C, which I love because I'm starting to try and move everything in the house to USB Type-C, and this can be input or output as required. And these two thingies, you can see here, they are outputs. And we also have a cable, micro USB, and then a micro USB to USB Type-C adapter, which is nice. I do think I have a few of those, but anyway. And what's quite important, they tell you that it's okay for check-in. I think the limit is 10,000 milliamp hours, if I remember correctly, for checking in planes. Let's see. Yeah, they give you some info here, extra hours based on talk time for the Galaxy S8. Jeez. So this is not that new also, because we are talking about the S8, but still newer than this one. So let's see. Can I open the pack or not? I think not. I got this from a family friend. They received it from the network provider for free, and they were not using it, so they remembered I use these kind of things and gave it to me, which is perfect, and I thank them once again. and we are in German. So we kind of, I showed you already what was in English. You can pause and read at any time. Nothing to see there. Just dropped the adapter because why wouldn't I? Quite snug in there. Be back in a second. And I'm back, and this is the little adapter. Gold. Yeah, really. That doesn't matter that much as you might think. Come on. I rarely, and I mean really rarely see oxidized adapters and contacts and whatnot. They need to be in a really bad environment to get oxidized. So this is its cable. I'm going to plug this thingy right in here to adapt it to USB Type-C, any die now. So in theory this will stay like this as a backup because I do have other cables. So I don't think I'm going to use its cable. Although, wait a minute. I think I'm going to actually use its cable for testing both of them. Because this should be able to handle 3 amps. They put it in the package. So if it's not handling 3 amps, it's kind of their fault. And many people might use this cable. So yep, I am using this cable for our test in the end. For the size of it, I somehow have a feeling that this one is a bit heavier, but not by much. They are comparable, but this is a bit heavier. Different shapes to them. This I'm 99% sure it has two 18650 cells in it. So they are the type of cells that you would find in a laptop battery. They are cylindrical and two of them right next to the other. Here I'm expecting to have some flat lithium cells. Again, same info in gold. You can see LEDs blinking on both of them. Zero power in here anymore. Now I will do the charge test with this, which will be plugged into this Huawei adapter that can provide 2 amps at 5 volts. None of these two can take more than that while charging. This will show me how many milliamp hours go into this while charging. This cable is rated at 2 amps and I've actually seen it delivering more than 2 amps. So for sure it will not be a limiting factor in our test. It's kind of annoying because it's a ribbon cable. I will link the video in the description, but it's a thick ribbon because, yes, again, rated at 2 amps, but it actually does more than that. So our setup will be something like this, and ta-na-na-na, 2 amps max. I'm not going to put a timer to see exactly to the minute when this charges. I am going to try and monitor them and see which one of them charges faster between these two, but not to the minute. I'm more interested to see the charging current. If we have charging current bigger on this one than this one, it's clearly this one will charge faster. Charging current tells us the whole story. And the test has begun. So we are pulling 1.75 amps, which is less than 2 amps, but still close enough. Here we started from 0 milliamp hours. We'll see how much we can put into that battery. That's the voltage, close enough to 5 volts. So everything here is rated for 2 amps. This is the limiting factor, if it actually does 2 amps or not on the charging part also. In theory it's written there, but we cannot see it anymore because we plugged this in. And it's 10:20. Let's see how this goes. And 5 hours later, this is much more charged. 8,392 milliamp hours pumped into this battery, and the current is starting to drop, 1.14 amps. So that is telling us that this battery is somewhere between 80 and 90% charged. And we are fully charged. It didn't take this long, so I missed the moment when it got fully charged. I'm expecting somewhere around 6 hours, maybe it was. And the capacity 9181 milliamp hours. And you can see we are drawing no current anymore from the charger. We are fully charged. So yeah, now I'm going to start to use the power from it and see how much it can actually give us, because it will have internal losses for sure. Plugged this in, and this will be plugged into the phone that I'm recording it right now with. This is in here, reset. Just want to point out, obviously, this is more than the phone has battery. So I will also charge my phone tomorrow with this, because this thing knows how to add. So even if I stop the charging, it remembers the last reading in here and it will continue to add to it. So we can see the maximum capacity of this that it gives into my phone, even if I charge it in 2 or 3 separate occasions. Nope, no matter what I do, doesn't go above this, so I will try with this little guy. And yep, this little black cable seems to be doing more than the other one. Why exactly, I have no idea. Again, that one was rated for 2 amps and we almost got 2 amps while charging. But while discharging this thing, it didn't go higher, but this one is going. So yes, they did provide a good quality cable with this thing. Only thing that would make sense for me is these cables are way longer than the one provided with this, so they have a higher voltage drop and the phone refuses to pull a more current because of the lower voltage. That's the only thing that makes sense to me. And we are done. There's no more juice absolutely in this thing. It will not power on anymore. Managed to charge the phone, the Huawei P30 Pro, the second time from about 15 to 20% to full. So this thing can do 2 charges of my phone from about 15 to 20% to full. That's about it. And now let me show you how many milliamp hours we got actually from this thing out. We saw how many went in without calculating the losses and the efficiency of the circuit, and now we can see how much we can get out, and the efficiency is all taken into consideration when we get out. Ta-na-na-na. 5732 milliamp hours we could get out of the battery, although we basically put about 9000 milliamp hours in, more or less. So this shows us that these power banks, at least the older ones, I'm showing you the charger, I forgot, I'm not plugged into the power bank now because it's depleted. The older ones at least are not that efficient. And I will link a few links with articles in the description that actually show power banks are highly inefficient, much more than I had ever expected. So, in the end, reading those articles, I realized that these numbers on power banks don't mean much in theory, because you will never reach them. It depends how the manufacturer decided to actually measure this, or actually not measure, more or less calculate this. And yeah, we got out of this the value that I showed you, over 5000 milliamp hours, but at 5 volts. So that means that we have about 25 watt hours into this thing available. Watt hours is actually what they should write on these things, not milliamp hours, watt hours, like we have on laptop batteries, because that actually takes into consideration the voltage that this thing is outputting. And the battery in the cell phone, mine has 4200 milliamp hours, but at 3.7 volts. So if I would do the math, I think is it about 12, 12 and something watt hours around there, maybe just a bit more, or 15 watt hours, but I did not charge from 0%, I did from about 15 to 20%, so it means that I only needed about 12 watt hour to charge the battery, and this is why 25 watt hour in this actually managed to charge my battery twice. So again, these values, yes, give you an idea, but you will see in the links that I will put in the description, don't mean that much. But both of these output at 5 volts, so I will be able to test old technology with newer technology. These are round cells, lithium ion, and these are pouch cells, the flat ones, lithium polymer presumably. So next we'll be charging this one with the same cables in the same situation and see what we get. So it's about 7:20 in the morning and this thingy is beginning to charge. 11 amp hours up until now, charging at 1.64 amps. It jumped up to almost 1.9 amps. So we are basically getting the 2 amps charging that it says. Still charging, obviously. About 3 hours and 10 minutes later. Charging current still high. Almost 1.9 amps. So we are getting the 2 amps. And 6000 milliamp hours we put into this thing up until now. Well, it's fully charged, but I was away, so I'm not exactly sure at what time it finished charging. As you can see, not drawing any current at all, and we actually have less of a charge, 8606 milliamp hours compared to the other one. But yes, it might get higher a little bit more, because this is its first use, and lithium cells don't require formatting, but they still rise a little bit in capacity after the few first uses. So maybe, yeah, think about it as maybe 9000 milliamp hours, but honestly, still a little bit less than what they said, or at least a little bit less than the other 10,000 milliamp hour unit. So now, let's start and discharge it by charging my phone and see how efficient it is. The other one was really inefficient. Charging for a good while now, as you can see, at 1.8 amps. This is what we put into the phone at the moment. Actually no, we did not put this into the phone because this is at 5 volts and the phone has 3.7 volts, so this value will change. This is what we took out from here. That's better put. Let me test with the tiny cable and see what this will give us, more amps or not. On the other thingy, it gave us more amps. Nope, not seeing more than this no matter what. But we can clearly see that voltage is higher on this unit than on the other one. And I'm thinking that this unit, yeah, you can see the changes in milliamps, it's varying. But on this unit, with this cable, we never saw more than this. Never, no matter what I did. So all the outputs should be rated at 3 amps. But the total is 3 amps. So if you have 3 devices pulling from this, presumably they will get about 1 amp each. And yes, it is beginning to scratch, as you can see here. So this will be scratched, all of it in no time. But I don't care about that. Anyway, so there's that. It's good. Good stable voltage, I like that. Now let's see its real capacity. Also trying on the USB Type-C and see if I get more than 1.81 amps. Also tried with the 5 amp cable. I didn't get on this USB. I'm also not getting it here, but I'm only checking it through the phone software because there is no other way. This doesn't plug into a Type-C. So no, my phone doesn't want to pull more than 2 amps from this thing. It could, maybe this thing provide more than that on a single port, but my phone doesn't want to get it. And this little guy is fully discharged, not even trying to power on anymore. And we have drained the whole battery, and this is the end capacity that we drew out of it at 5 volts. So that's higher than the other one, the Hame, but way less than what we put in, so this thing is again quite highly inefficient. And that's about it for this video. So this does have a higher capacity, but not by a lot, and the value of it, the advertised capacity, where is it written? Isn't it written anywhere on this battery at least? Oh, it is here. So in milliamp hours, I don't know how they calculate that, but you are not getting that out of it ever. I can tell you for a fact, and again, check out the links that I put in the description. They tell the whole story behind this thing. So, yep, that's about it. They are good. You don't really have other choices. I don't think there are ones that are highly efficient out there, or if they are crazy expensive, so I wouldn't bother with it too much. Just use what we have, but take it with a grain of salt, because the real capacity is tiny bit different than what is written on the packaging. And yeah, that's about it. Quite a long video, but hope it clears out some things out there, in which case please give it a like, check out my other videos, and as always, see you in the next one. Bye.